You get the point. What I will do, I will print them out, and then you'll come here. And that's on the paper, so you check and give back to me. All right? So that's so this is a graduate level course. I will treat you as my research student rather than to kill you with a homework or a presentation. There's nothing really serious. So you can just present whatever you want. Okay? No set up topics. It's based on your significance of your question you pick, you want to study, innovation, how creative you pick that particular topic, you design your experiment analytically, okay, all computational based. Then your approach, how you are going to solve or validate or disqualify your hypothesis, the question you set up for yourself, and then your performance. So how you present yourself and make it easy to understand logically and also faithfully test your hypothesis with the right approach. So that's the criteria to be considering, and for your oral presentation, then you will get the score and the weighted 1/3. At the end, you will have a total. So then you will get A or B and C and a certain cutoff. All right? Is that clear? So I know as a student, you care about your final score, and also, again, this is a graduate level course. I don't want you to spend too much of time on those. You learn what you need to learn, and then feel comfortable with the content and reshape yourself, change your mind, considering what state you are at this moment, and after 12, 13 weeks, and you come back to review and you learned something, but not, this is just give you some incentive to learn, okay? So this course has been taught several times. We start from 2019, okay? And I don't know, you have asked previous students took this class and what their experience are. But in general, we want to reshape the mindset for biologists. As your background, I think most of you from the molecular biology, genetics, I don't know, animal science, maybe pathology, whatever. But you need to change your mindset to understand the principle behind those machine learning methods. Nowadays, more relevant AI models. When bioinformatics and the people publish a paper, they have equations, they have algorithm design. So you need to have a basic understand and feel comfortable about reading those papers. Sometimes you can re-implement some of those methodology. So my name, James Kai. So this is a Chinese pinyin spelling. So we pronounce as a Tsai. So it sounds like T-S-A-I, or it's like in Greek letters, Tsai. So it sounds more likely Kai, but it's okay if you call Kai using English pronunciation. Okay, that's fine. So this This is a Chinese name. So I want to know your name, your research background, and your programming skill level. So what language you are using and at what level. So let's start from Wagnish, and then we take a turn and to the center. All right, so that's a experiment circle. So your name.
My name is Vignesh, and I'm doing PhD in biomedical science, and I work on the doctor side. And my research area is in quantum computing, network science, and single cell optics.
And your language, your computer language.
I use Python, MATLAB.
Okay.
Hi, I'm Michelle. I'm a second year PhD student in biomedical science as well. I'm in Dr. Levesque's lab. So we're studying foodborne safety and work with salmonella in the next PhD as well. I don't have much experience. I have a little bit experience in bioinformatics. I mainly work in data, but great.
Yeah. Microbiome.
Hi, my name is Vinity. I'm a graduate student in the biology department. I'm in Dr. Thompson's lab, and I am working on the phytosteron. And for the language, in my lab, they are mostly using the R.
Mm-hmm. Okay. Yep.
Hi, my name is Felix. I'm in Dr. Josie's lab, and I transferred here earlier last year on the biomedical science program.
Yeah.
I study oral hydrocarbon receptor and working for kinases for their role in liver diseases.
Okay.
In my lab, I mainly we do omics, but usually we collaborate as well. I've been doing them by myself lately just to get my hands on mainly like bulk RNA sequencing and some single cell.
Yeah.
I mainly use R and batch, but I don't know much about the MATLAB and other languages.
Okay. Yep. No problem.
My name is Boston. I'm a PhD student under Dr. Sakura Kano. So we study about the impact of chromium on reproductive system. I don't have much of an experience in biomedical science, but I have some analytic background of art.
Yeah. Okay.
Hi, my name is Indra. I'm a second year PhD student, and I also come from the same lab as him, from Dr. Banu's lab. And regarding the programming, right now I'm switching a little bit to bioinformatics. Not that much of the programming.
Okay. Yeah. So Vicky have taken this course before, so you know that. Okay.
Hi, my name is Avery, and I'm a first year PhD student working under Dr. Chu.
Yeah.
And so we're working on urinary biomarkers for feline safety.
Yeah.
I don't have a lot of experience with programming. I did have some exposure to it in my undergraduate lab that was single cell group that I was involved.
Mm-hmm.
Hi, I'm Selena. I'm a master's student in the veterinary technology program. As a work programming language, I've worked quite a lot with Python. I know background in MATLAB as well. I'm working on a project with Dr. Levesque
Yeah.
to model machine drive decisions.
Mm-hmm. Yep.
Hi, my name is Marcos. I am from Brazil. Nowadays, I am a business schooler in Cabo. I work with refining production. And as a visiting schooler, I cannot take courses here at Cabo, but Dr. Hay has kindly authorized me attending his classes as an author.
Mm-hmm.
Currently, I am working for RNA sequence and differential gene expression in uterine tissue of Mars with obesity and endocrine diseases. Part of my PhD is on Tamil and part of my PhD is in
Brazil. How long you will be here? How long you will been here? Until July.
9 months.
Okay, good.
I don't have experience in bioinformatics and this is my first work.
Okay, sounds good.
Hi, I'm Parinita Michelle, and I'm a PhD student in the Shetty lab. So in our lab, we work on stem cell-derived extracellular vesicles
Yeah,
for treating various types of neurodegenerative diseases.
yeah.
So about my knowledge in programming, so in the past I've used R for data visualization and analysis, and to some extent I've used MATLAB for data analysis as well.
Yeah, so I know a lot of people in Shetty's lab. Yeah, we have collaboration. Yeah.
Hi, I'm Avantika.
Yeah.
I am a second year PhD in the Department of Biology.
Yeah.
I'm in Dr. McCready's lab and I work with inflammation of the spinal cord injury. With regards to my experience, I have used MATLAB, Python and R, but it's mostly from like data analysis viewpoint as well as I do know some, I have some background which is probably, I would call it intermediate level at this point.
Yeah. Sounds great. So this course is exactly designed for all of you and this with a strong PhD level biology background researchers and with some of this bioinformatics exposures in different languages. So language is not really important at the end. So you can do the same thing with R, with Python, with MATLAB, with Julia. There's some emerging new languages as well. We will have Tuesday like this lecture, and then Thursday morning, same time, we will be moving to 115. That will be a computer lab. You will work on those computers. I will lead you through all this practice, through real data analysis, through this computer-based, computational-based exercise to make sure you know the basic language, the operations of those necessary for you to take off. And I will introduce you to the interface I designed and Dr. Shetty's lab used extensively. I can tell to help you go through the pipelines of the single cell data analysis from the very beginning to the very end, the high level analysis across the whole spectrum of the aspects of data analysis, make you feel comfortable at the end, no matter what language you are using. And this is designed for biologist background people because all the stuff I teach is not in the same way you will take the statistics or engineering computing class, which people will not explain to the very fundamental level. But I will create this environment which we build understanding for those algorithms, for those operations, exactly, and how they work. So make sure you understand every single element of the concept. Okay. Sometimes it's high level. So for example, we study gene expression variability rather than the mean change. Sometimes it will be very fundamental in terms of algorithm design. You will see how the data points will be rotate and to project from one space to another space, increase or decrease the dimensionality, and why they are doing this. Okay, so very, very detailed. And there are applications as well. We have algorithm built for the whole solutions for the classification. For example, in the urine, in the small animal clinic, people will have a collection of the samples and then based on the profile of those samples and to classify what subtype of disease. You will be able to build applications yourself, apply directly to those kind of well-defined problems. But more importantly, in single-cell data analysis, there's unknown territories. You need to have a very strong understanding of fundamentals before you can explore and combine those different algorithms to apply to the new questions. It's not like we have a classification problem. We want to use random forest to do this. You certainly can build this very easily. I can show you how easy it is, but in reality, you don't have those good training data in single-cell data analysis. Especially you collect your own data. It's different from anyone else. So you have to have a very strong mindset of how this data points can be manipulated before you can do anything really substantial to find unknown, not directly insights from the data. So that's what we try to do. So the first class, as an introduction, we will go through some of the basic understanding of this machine learning, how this whole field has been developed over the time. I think this year is very meaningful to understand this development as a history. It's very different from 2019. At that time, we don't have a ChatGPT. We don't have a large language model applications so widely. At that time, people never heard about it, ChatGPT, although the transformer, the framework or architecture has been established, but not at this level. This year, we are talking about AGI even, okay? So what AGI? Artificial general intelligence. Basically, we want to develop this machine learning algorithm can learn itself, which have a general level of understanding of the world, not only the language. Okay, language model already, large language model. So this transformer architecture has been already so powerfully built into this. So we are having language model every couple of weeks. I have a new version. You have ChatGPT 5.2 now. It's better than 4.1. Okay. So this is the background. Any logistic question you have so far? It's okay. So examinations, how this will be at the end, give you the credit. This is a name. AGI this year. Okay, so we start from. So single cell. So today we will discuss machine learning, and also we will, at the end, you will have to be able to explain how the single cell technology allow you to get individual cells gene expression. Okay, so you need to, at the end, understand this barcoding system. So this individual cell mRNA barcoding system was invented and developed, I would say, as a parallel revolution, as a machine learning developed this way, and the single cell data, the barcoding system developed that way. So in 2017, so this is the beginning of the revolution of the single cell technology. Single cell technology really started from that year. So the class was built right after we digest the data analysis approach, understanding this. So I start to teach this class. So this is outline for today. So we will have a very general introduction, what machine learning is, what AI is, and the development of machine learning method, and then how are we going to learn this, okay, in more generally discuss the approach you should consider. And then introduce how this single cell technology working, how this barcoding system works. How many of you believe you know how this barcoding is working? Single cell, how this single cell gene expression, each mRNA has been labeled. Nobody knows. Okay, so after in 12 in the noon today, you should be able to understand. Okay, there are two different major systems that people use. So let's start with this video. So this is from a primary research institute in Kyoto University. Okay. Let's use this YouTube to. So this is the name of this particular chimpanzee, so Ayumu, okay? So it has been trained to do this test. So how many of you have seen this before? Oh, someone, okay. By the way, this is from the Kyoto University Primary Research Institute. This institute had been, this particular site had been closed because of some misconduction of this research fundings by the director. Okay, there are some stories after this, but this research is interesting. So this makes our thinking. What when you see a tail or someone is smart, this AI is very smart, and this particular chimpanzee, she's very smart. What that means is the animal have a very different human working memory, which its evolutionary trajectory different from humans. What human can do, we can build AI, we can build a machine learning path to approach this silicon-based AGI intelligence build up. Our capacity is not by our working memory or what, compared to the chimpanzee. We are good at tool use. I learned this from another Academy of Science American members. He classified human tool use into several ages. So we start from Stone Age. So we spend most of human as a human being, as a species, spend most of the time in this Stone Age to use the tools. Well, we spend most of the time in the Stone Age before. Then we move to this Iron Age or Bronze Age, which people knows how to do this. Hammers, shavers, and so that increased our productivity more in the evolutionary relatively short period of time. But today we are in the Silicon Age, which we build AI around this chips. So this age of information. That's right now we are here. So machine learning is a computer science subfield to let machine to have ability to work, to learn without logically program each steps, but let the machine to do the thing. I'll give you an example. It would be so-called PageRank algorithm. So this algorithm will iterate all the nodes in a network. And through this computation, to compute the value of each node to give a rank. So depend on the information goes into the page, this node, and also information go out. So how many goes in, how many goes out, to compute a value. So this is algorithm, is one of the machine learning approach to assign the values per page. So this is so important because it's gave the birth of the Google. So if you, in the 1990s, if you have this algorithm, you have a foundation, you have some basic value algorithm know-how, you can build the whole company out of it by itself. So it's relatively easy. So you, at the very beginning, you gave equal weight for each node. So at the very beginning, you gave, because you have 4 nodes on this small example, so you gave 0.25 weight for each node. Then depends on your topology. So this node will contribute 3 outputs. And this contributing weight gave to 3, separated into 3 parts equally, and gave to the next level. The page is 0.2. And then through this simple loop iteration algorithm, you recompute the value, and then you do this again and again. Then at the end, the whole algorithm converged, and the value of your page or each node in the node network will not change anymore. You stop there, and that's the value for the so-called page rank. Okay, let's give a name. A quick question is, based on the definition, the machine learning will learn this, what to do automatically without a human touch. So whether PageRank, as I described, is a machine learning algorithm or not, people still argue about it. Some people say it is, and another group of people don't believe it. So it's really not so important, but just let you know. So there's a clear definition what machine learning is, and which behind the AI, and it's built upon all these algorithms. So PageRank algorithm maybe contribute a little bit, but it itself may not become a machine learning algorithm itself, but it certainly can contribute to build machine learning algorithm. Okay, so we try to let it to learn automatically without explicitly programming. So machine learning can be, algorithms can be classified into supervised, unsupervised, and reinforcement learning. So we will focus on these two because in biology, we don't have a ground truth allowed. So when you do the reinforcement learning, you need to have a large number of these user cases, and you know the next step you move will increase or decrease your fitness of this particular object. So you have a feedback, but in biology, we don't have a lot of those. So this is not a good user case to learn reinforcement learning in biology, but we certainly will focus on supervised, unsupervised learning. So supervised learning, including the most common ones, people will consider classification and regression because you need the training data, not a large amount, and not those like reinforcement learning. To do this classification, to do the regression, Well, unsupervised learning, including dimensionality reduction and clustering. So in that case, you don't have to train the algorithm. The algorithm will do the job and for any data given to it. So like classification, any given data, apply this algorithm, it will be allow you to group data points into different classes. So this is an example of supervised learning. So when you do the regression, you need to have those data points you collected. What you want to do is to build a straight line here to go through the middle of this data points in order to minimize the distance in terms of y-dependent variables values when you gave the prediction using the x values. So this straight line is created not randomly, but is searched or approximated through to learn this data points distribution. Okay, so that's why linear regression is considered to be a supervised approach. So this knowledge point could be at the end of the final exam. I will have a question, say, okay, which the following algorithm belong to supervised algorithm? So I will have clustering, I will have regression, I may have SVM, and others. You tick one. So that's the place which you can consider to learn if you don't know. So SVM is another example of supervised learning. SVM stands for super support vector machine. So these 2 points here, so this one and that one in the boundary of this separation line is so-called support vector. So this algorithm will look at the distribution of these 2 different classes of data points. One is labeled as black, and another one is as open, the white. This algorithm will learn the distribution and found a separation. This line will be separate these 2 classes of group of data into 2 classes, and correctly and most robustly. When I say robust, it means this line has to be away from the black and also away from the white. Okay, so even you have some perturbation of the accuracy of those lines, these points measurements, you still can use this separation line to separate them. So this right line is correct support vector separation plan. You can separate these two set of data points as H1. This blue line also will do the work, right? But the right line is the correct answer, the most robust separation. So that's a support vector machine will do that job. Again, you need training data which supervise the algorithm to find this right line. Okay? So that's why it's called a supervised algorithm. In AI, in machine learning, we do a lot of neural network. Again, those neural network, inside the network, there are nodes. Those nodes have been associated with the node weight, different values. So those need training. Okay, so neural network for classification purpose are supervised approach. So what are the examples of the unsupervised algorithm? So PCA, we will spend a lot of time on PCA because PCA alone will cover, I would say, 1/4 okay, 25% of all machine learning foundation. I will see that again and again, maybe greater than 25%, okay? I'm pretty sure all of you heard about the PCA, and who haven't heard of PCA before, Principal Component Analysis. You haven't heard PCA yet. Yeah, it's all the machine learning is based on lineage algebra. So PCA is a way to help you to use lineage algebra to rotate your data points in order to represent the most variability inside the data points relationship. So this idea is behind almost all the machine learning methods. I would say it's greater than 25%. So this is very important, but it's unsupervised algorithm. Okay, so you apply PCA to any given data sets without training. It learns the structure of data, the relationship between data points by itself. Classification, clustering algorithm, the k-means as a most famous examples will not using training data. It's directly applied to the data points you gave to it. It will cluster your data points into different clusters. Any questions so far? Supervised, unsupervised. So later I gave you one example and you should be able to tell me this is supervised or non-supervised. So this page is certainly out of date. AI, machine learning methods have been applications in all fields we have. Nowadays we build agent, okay? Agent, so AGI, so AI, agentic. So AI agent become a very active research field. So we will have some examples later. So how we design AI agent to let the agent to do something. Okay, it's based on the ChatGPT language model, for example. And then using another agent to do something else, and they can collaborate to finish a more complicated task. We will have some examples later. So when we see AI machine learning, most people will not think about lineage algebra. Most people will think about the neural network. So this idea was started from 1940s. So people start to think about we can use this computer program to simulate neurons. Okay, so neurons will take some values as input and aggregate it. For each input, you have a different weight, and then you see this sigma, big sigma. So the neural network will just summarize every elements. So if you have 3 input, then this I equals from 1 to 3. So you just add them together. So once you have one neuron, you can build another one which next to it. At the end, you build a network. So this is the very beginning people to start. Even we have a real laptop computer or desktop computer. And at that time, the computer is taking the whole room like this. Alan Turing have this intelligence machine history right up, and then in 1950s, Arthur Samuel, who I gave you the definition of machine learning, he already designed this algorithm to do this checker. This is called the world's first self-learning program. 1960s, so I just pick some of the random data time points to show some representative algorithms at that time, which had, the ideas had been born. So this is the idea which SVM support vector machine is so important in machine learning field. People use it to do the classification, but the algorithm idea start from 1960s, and then I think this is the starting of this Moore's law description. So there are exponential increase of the computational power by 18 months. So 1970s, Stanford have designed this automatic autonomous vehicle. 1979, the convolutional neural network idea was introduced. So this is called the CNN, so it's particular type of the neural network. So neural network, and then you have a CNN. It start to recognize the image. There's a dog, there's cat, okay? So the idea already in 1970s, but at that time, the computational power is not enough. The training data is not as sufficient as enough. So the idea is there, but very poor performance in the picture or image recognition at an early stage. Self-organized map, the idea is one of the unsupervised learning approach. Then the Bayesian network, 82, simulate annealing as a optimization approach. That's 83. So this is a gradient descent. So that's the algorithm widely used almost every day, every algorithms in the optimization field. Then SVM was reintroduced by the original author and also co-authors. Applied. 1990, reinforcement algorithm. 79, IBM have this chess machine to beat the Deep Blue, beat the chess champion. 1908, PageRank algorithm has been introduced. 1998. I hope most of you have already been born, right? Maybe not. 2005, GPU. Okay, so this NVIDIA GPU has been used in training as a hardware and for the CNN, for the neural network. Self-driver cars. Okay, as I said, CNN was not so successfully applied in the image recognition until Fei-Fei Li had this human annotated. She spent a lot of efforts to organize undergrads and to manually curate the pictures, label. So here is a computer, here is a bottle, here is a cable, manually labeled maybe 300,000. I don't have a good number on it, but it's large image repository with labeled. So this changed the whole field because people don't realize how powerful this is, almost abandoned this algorithm. But the training data is there, and then the power of this emerged immediately. So the accuracy increased from 70% to 92, somehow very high level. So the large scale visual recognition challenge, and then those AlexNet, this particular algorithm using CNN has become a champion, and then it opened the whole field. People realize it's very useful, and then start this the booming time for the AI. So that's 2010. This is very recent, and I don't know if any of you play Go. This ancient board game, and you put white, black stone in there. They're 19 by 19 and 361 cross point, so you can put either white or black stone in turn. And then there are combinatory possibilities over the certain number of this. People didn't believe their AI can beat human champion. It's much earlier than people expected. So in 2016, and this AlphaGo beat the best Korean champion in the Go game. All right, so this is a very brief machine learning timeline, 50s, 1940s, 50s, until most recent AlphaGo, and beat human champion as a timeline I collected from the information on in the internet. But certainly after that, 16, 19, and I think ChatGPT was introduced 2022, and everything changed. So that's why we are starting to talk about to build an agent, AI agent, to build artificial general intelligence. So the whole field will continue and change very rapidly, much quicker than you expected. Because this silicon-based algorithm, once you build one, you can copy, okay? The incremental, it's exponential easily. Really interesting point. So this is again, and the 2020, the Moore's law reached to plateau maybe. I don't know whether this will increase because there are physical limitations for the 2 nanometer chips, and it's already hit the boundary of the atom size, so we probably not be able to see the continuously exponential increment. So it could be people start to use quantum qubits to design algorithm that for some of these applications. Not every algorithm we designed for current machine learning algorithm can be easily translated into quantum version, but some of these algorithms we believe will be able to accelerate it using quantum computer. So this is a quantum computing timeline that's developed. So the idea was introduced, proposed by Feynman, Richard Feynman. So he said, okay, we should using quantum computer to simulate quantum phenomena in the quantum mechanics. Certainly, there's some of this physical phenomena in the quantum field may be very hard for the classical computer to simulate. But it's straightforward if you design the quantum computer to simulate the quantum mechanic phenomena. It certainly will be straightforward. But then people realize maybe we can use quantum computer to solve some more generalized problem, not only focus on the quantum phenomena simulation. So through the development, also the investment of the big companies, we start to have the prototyping of some working quantum computers already. And nowadays, the best application for quantum computer, do you know what it is? It's a generate a random number. Okay, it's a really, really random. But yes, people are, including my lab, is thinking about to use quantum computer to do the algorithm to simulate some of the phenomena which are hard to simulate by classical machine. Okay, there are applications in financial, in material, in chemistry, in the optimization, okay, in different fields already. I think we can take a 5-minute break, and then let me know if you have any questions for the first part of those talk. Okay? 5 minutes break. Come back at noon. Okay, so I will introduce how in general language, how this machine learning, how the machine will learn the new stuff, basically how the neural network will work to get it trained. And then we will move to how are we going to learn machine learning methods, okay? So after that, then we will quickly move to how this single cell barcoding system works. So the machine need to collect data to prepare and then start to build up the training model. And then you evaluate this model by using the set up the data and then tune the parameters within the algorithm, just like you learn the new things and change your mind side, and by changing the connection of your neurons and maybe permanently, you learn new things. So this is also how the machine will have training data, and this is human select the correct algorithm to put in the machine to train the model by giving the model the algorithm, the training data, and then the test, and then applications. So how are we going to learn machine learning? How we learn this method overall? You need, number one, most important, okay? There are many textbooks, but if you don't have this, you're lost. You don't know how to manipulate those data points. You need to have a basic understanding how you count, how you measure the mean, the deviation. This is very basic, okay? Sometimes I just feel it's intuition, so you need to compare this and look at the distribution and take into account of the variability of data points as a group. So nothing very specific. You may need calculus when you need to do this optimization. You know how to move the the curve from one to another. So, but not essential. And to do algorithm and complexity analysis, you probably need some of this, but not necessary. But I would emphasize linear algebra, so the most important ones. This is a foundation. So when you try to do this yourself, if you go online, you may find, okay, there are a lot of machine learning tutorials, something like this. Hello, world, we can learn machine learning by look at this very simple, only 6 lines Python code you can do. I think this is a decision tree classification. You may have a lot of this kind of tutorial in YouTube, in another websites. I would say without this is useless because it gave you which well-packaged library ask you to use. This is like some APIs you can use by calling this library or building function inside this scaling package. So it's useless because you don't have understanding of what they are doing with the decision tree, is navigating the decision branch in there. What the feature is, what's the label. So if you don't have those, you only copy this, it's very useless, okay? You can have R, you have R package, other people develop it. You can call this, but useless. You can do SVM by using 1, 2, 3, 4, 5 lines of code, but you still don't know what they are doing. So this is a black box method. So that's not the way we are going to teach you. I'm not going to teach you any of these libraries. You can read the tutorials if you want later, but we will go linear algebra from the very beginning of the definition of the matrix, how to do matrix multiplication, until you understand what they're each step. Another example of this machine learning for biologists. I don't know where I get this, but PCA in Python is pretty easy. Yeah, so it's easy. You have a scaling and then import PCA, and then you organize this data into frame, then run the PCA. I don't know what they're doing, but again, don't look at useless. Okay? Don't even look at those. Learn this and explain PCA in your own language. After lecture 4, you will feel comfortable. Those are the very superficial. There's one way to use the package. Also, this package evolved as well. So next year, maybe another package come up. We'll superimpose onto this and say, okay, we don't need this, we need something else. The change, but the rule, the core, and how you manipulate the data points, the way you use multiplication of matrix to do this will not change. Goes another way. So people also have something like this. This is probably from the computer science people or people with engineering computer to write those gentle introduction of how SVM works. So you got a bunch of those, and you're scared off because too complicated. So even though this is so-called gentle introduction, but there's no way for you directly to penetrate all this method. Again, we will gradually build on this and help you to understand all these symbols and what they are doing. And at the end of this study, you will feel comfortable to read those kind of gentle introduction for sure. For the bioinformatics paper in the supplementary, there are equations, there are description of the fundamental steps, which using mathematical language, and make sure you understand some of those. Okay, link back to your linear algebra operations. Another, I found from YouTube, someone list, okay, you need to learn machine learning through, you need those elements. You need to choose a language. You need to take an online course by Andrew Wu, and he's a professor in Stanford. You can read a book, Deep Learning, and the basic sklearn and Python. I don't use those. Okay, I don't know. Deep Learning library. So there are some this advanced suggestions as a machine learning expert to give to you. You need to those. I would cross out a lot of those, and I don't believe their recipe is useful. So don't follow them. We have our own way to use our time wisely through this course. And for the language, this particular one I will help you to use MATLAB. There are some good reasons for that. You will learn gradually. I'm not against any other language. R is good, greatly, widely used by statisticians. Python is, of course, the #1 computer language in machine learning field. Will make your life very easy if you learn this. There are other languages like Julia is much younger, and then it's invented maybe 2016. I don't know, but it's a new language. Julia looks very, very similar to MATLAB. There are good things, bad things of each language, but by chance we are using MATLAB there in this. You may want to have a GitHub. I don't know how many of you have a GitHub to save your daily practice of your coding, and it's a place where you can save your programs
Let's face it. Most of the insurance industry can feel a bit prehistoric, impersonal, and confusing.
Hello everyone, let's check out what are the 5 must-have skills to become a machine learning engineer. First, let's understand what machine learning is. In simple words, machine learning is all about making the computers to perform intelligent tasks without explicitly coding. This is achieved by training the computer with lots and lots of data. For example, detecting whether a mail is spam or not, recognizing a handwritten digit, fraud detection in transactions, and many such applications. Now let's see what are the top 5 skills to get a machine learning job. At number 1, we have math skills. Under math skills, we need to know the probability and statistics, linear algebra, and calculus. Probability and statistics. Machine learning is very much closely related to statistics. You need to know the fundamentals of statistics and probability theory, descriptive statistics, Bayes rule and random variables, probability distributions, sampling, hypothesis testing, regression, and decision analysis. Linear algebra. You need to know how to work with matrices and basic operations on matrices such as matrix addition, matrix subtraction, scalar and vector multiplication, inverse, transpose, and vector spaces. Calculus. In calculus, you need to know the basics of differential and integral calculus. At number 2, we have programming skills. A little bit of coding skills is enough, but it's preferred to have the knowledge of data structures, algorithms, and object-oriented programming or OOPS concepts. Some of the popular programming languages to learn for machine learning is Python, R, Java, and C++. It's your preference to master any one programming language, but it's advisable to have a little understanding of other languages and what their advantages or disadvantages are over your preferred one. At number 3, we have data engineer skills. Ability to work with large amounts of data or big data, data pre-processing, the knowledge of SQL and NoSQL, ETL or extract, transform and load operations, data analysis, and visualization skills. Next, we have the knowledge of machine learning algorithms. You should be familiar with popular machine learning algorithms such as linear regression, logistic regression, decision trees, random forests, clustering like k-means or hierarchical clustering, reinforcement learning, and neural networks. And finally, the knowledge of machine learning frameworks. You should be familiar with popular machine learning frameworks such as scikit-learn, TensorFlow, Azure, Caffe, Theano, Spark, and Torch.